आणि याला नाही कनेक्टेड. Good morning. Am I audible?
Yes, sir.
Yes, sir.
Okay. So yesterday we were discussing about the beam reaction. Okay. We have discussed about the different type of supports which we use for the beam. Beam is a horizontal member of a structure. An analogous member in the mechanical engineering is a shaft. Okay. Shaft is also supported. Clear, and to design that support, clear, we require to calculate the support reactions. Clear. So which are the different type of supports used for the beam? Clear. The first type of support which I told is the roller support. How many number of unknowns are there at the roller support? At the roller support, the horizontal motion is allowed. One direction motion is allowed. Rotational motion is allowed, but the vertical motion or the motion perpendicular to this supporting surface is restricted. Here, since the motion perpendicular to the supporting surface is restricted, reaction shall be a force in that direction. जो direction में motion restrict होता है, reaction वो direction में induce होता है. Clear? So at the roller support, the reaction is always perpendicular to the supporting surface. Clear? And initially you have to assume the direction. Clear? So if this point is A, then this will be the reactive force at point A, which is perpendicular to the supporting surface. So remember, at the roller support, the reactive force is always perpendicular to the supporting surface, and the direction initially you can assume. Therefore, at this roller support, since the direction of this reactive force is known to you, there is only one unknown, and that is the magnitude of this reaction. Sometimes the roller is resting on an inclined surface also. If the roller is resting on an inclined surface, the reactive force will be perpendicular to that inclined surface. Clear? And here also the direction is known to you, so this unknown is only magnitude. So this is one type of support which we have studied yesterday. The second type of support which we have studied, that was the hinge support. Here the example which was given are the pin joint or the hinge which are used for the doors. Okay. So how this hinge support is represented? Here, suppose if this is the beam, here at this end, or this is the body, at this end, this is the pin joint. This pin is connected to the bracket, and this bracket is fixed to some external support. Okay. Here, so because of this pin joint, the rotational motion is allowed. Here, but since this bracket is permanently fixed to some external support, here horizontal translational motion and vertical translational motion, both motions are restricted. Here rotational motion is allowed. Since the rotational motion is allowed, there won't be any reactive movement. Here, when linear motion is restricted, reaction shall be a force. When rotational motion is restricted, reaction shall be a moment. Here, since here the rotational motion is allowed, there won't be any reactive movement. But since horizontal and vertical motions are restricted, here reaction shall be a force in that direction. Here, so this will be the horizontal component of reactive force at A. This is the vertical component of the reactive force at point A. Or you can say this is the X component and this is the Y component of that reactive force. Here, by using the condition of equilibrium, you can calculate this. You have to always assume that the beam is in equilibrium, and applying the condition of equilibrium, you can calculate that support reaction. Here, now once you know this HA and VA, here you can calculate the resultant reaction. So this is the resultant reaction at point A. This is the resultant reaction exerted by the support on the beam. And this HA and VA are the component of this resultant reaction exerted by the support on the beam. Yes, so how we can calculate this RA, since it is the resultant reaction of this HA and VA which are perpendicular to each other, so it will be HA under root of HA square plus VA square, and let inclination of this resultant reaction with horizontal is suppose alpha, so this alpha equal to tan inverse of VA upon HA. So at this hinge support there are two unknowns. यहाँ पे एक unknown है. Here at the hinge support there are two unknowns. So which are the two unknown at the hinge support? Either magnitude of HA and VA, since the direction of HA and VA are known to you, or magnitude of the resultant reaction at A and its inclination. If you know RA and alpha, HA and VA, you can write. If you know HA and VA, you can write down the resultant reaction and its direction. Here, so at the hinge support there are two unknowns. So whenever there is a hinge support, we are supposed to show such type of two components of the reaction. Now, even if sometimes the reaction, hinge support may be resting on this vertical surface like this, or hinge support may rest on an inclined surface, so it doesn't matter whether it is vertical or inclined or horizontal. Here, As usual, you have to take the horizontal and vertical component of the reactive forces. Here, the magnitude of this horizontal and vertical component of the reactive forces will decide what is the direction of this resultant reaction. Here, at the hinge support, the resultant reaction won't be perpendicular to the supporting surface. Here, so whether it is horizontal or vertical, whenever there is a hinge, you have to consider the two components of the reactive force. Here, so at the roller, one unknown, at the hinge, two unknowns, and the third type of support is the fixed support. Here, this is the fixed support. Here, at the fixed support, there are three unknowns. Now, what happens at the fixed support? Here, rotational motion is restricted, horizontal motion is restricted, and vertical motion is restricted. Since rotational motion is restricted, reaction shall be a moment. So this is a reactive moment exerted by the support on the beam to hold it in equilibrium. Here, नहीं तो ये rotate हो जाता था. Okay, to hold it in equilibrium, this is the reactive moment. Now, since horizontal motion is restricted because of this support, reaction shall be a force in horizontal direction. Yeah, so this is the horizontal component of reactive force at A. Since vertical motion is restricted, reaction shall be a force in vertical direction. So this is VA. Here, so at the fixed support, there are three unknowns. Here, HA, VA, and reactive moment. In all the three types of support, initially you have to assume the direction, and with that assumed direction, you have to solve the sum by using the condition of equilibrium. After applying the condition of equilibrium, if any of the answer of that support reaction is negative, the magnitude is negative, then that negative sign indicates that the assumed direction is wrong. Okay, here, and the correct direction is opposite to that what we have assumed. Here, so this was the type of support which we have discussed. Here, then I told you that the beam reactions, which are the different type of types of loading. The next point, types of loading. Which are the different type of loading? Here, the first type of load was the point load or the concentrated load. What is that point load or the concentrated load? When the effect of the entire load is concentrated at one point. Here, suppose this is a 100 kilonewton load. Load means nothing but a force. Yeah. So when the effect of the entire load is concentrated at one point, here then this is known as a point load or the concentrated load. Till now, the load or force we have considered all are the point loads or concentrated load. Yeah. The second type of load which is used on the beam here is the distributed load. Now, name itself indicates that here this load is not concentrated at one point, but its effect is distributed over some length. Here, that's why it is known as a distributed load. Here, I had given you the example. Here, suppose if I am standing on the floor, the entire weight of my body is concentrated at one point. Here, but when here it is a person is slipping, here, so its weight is distributed over this much length. Here, so what is the distributed load? Here, so when the effect of the load is distributed over some length, then it is known as a distributed load. Now, there are two types of distributed load. One is a uniformly distributed load, other one is a uniformly varying load. Okay, so out of that, this uniformly distributed load is also known as a UDL, uniformly distributed load, and this uniformly varying load is known as a UVL. I am going to explain you what is meant by UDL and UVL. Out of that, the first one is the UDL. Now, name itself indicates that it is a distributed load. The load is distributed. But how the distribution? The distribution is uniform. That's why it is known as a uniformly distributed load. Here, the example of the uniformly distributed load, let's consider the self-weight of this beam. Here, let's consider this beam. Here, whether this beam is visible to you?
Yes, sir.
Yes, sir.
Now, if you consider the self-weight of this beam, here, what happens to the self-weight of this beam? The self-weight of the beam is nothing but the weight of that concrete and the steel. Okay. Here, now in this case, the self-weight of this beam, here for this 1 meter length and for this 1 meter length, this is the total length of the beam. अगर मैं ये 1 मीटर कंसीडर करता हूं तो इसका वेट, और 1 मीटर कंसीडर करता हूं तो इसका वेट, या तो कहीं पे भी 1 मीटर कंसीडर करता हूं तो उसका वेट. Here, the weight of this beam, self weight of this beam per unit length is remains same. Here, मतलब total weight is distributed over this much length. ये total weight distribute हुआ है, लेकिन वो distribution कहाँ कैसा है? ये 1 मीटर पे, ये 1 मीटर पे, ये 1 मीटर पे, वो distribution is uniform. That's why it is known as a uniformly distributed load. क्लियर? ऐसा होगा क्या कि ये 1 मीटर का वेट अलग है और ये 1 मीटर का वेट अलग है, ऐसा नहीं होगा. Okay, if it is the same material, here if the dimensions are same, here the weight of that beam per unit length will also remain same. Here, so if the load is distributed and if that distribution is uniform, then it is known as a uniformly distributed load. I hope you understood this, what is meant by UDL. Okay. Now this UDL is represented by, here suppose this is the beam, here it is a continuous beam, I am considering this much part of the beam. So this UDL is represented by such type of semicircular pattern. Yeah, this is the representation of a UDL, uniformly distributed load. Here, and let it is spread over a length of L meter. Here, and let here the intensity of this UDL, here इसको बोलते हैं intensity. This is the magnitude which is in kilonewton. और इसको बोलते हैं intensity. That let this intensity is W kilonewton per meter. It is W kilonewton per meter. Means 1 मीटर पे कितना लोड है? W kilonewton. Next 1 मीटर पे W kilonewton. Here, so it is uniformly distributed. Here, and intensity of that loading is W kilonewton per meter. Understood this? Here, so this is one representation of a UDL which is represented by such type of semicircular pattern. Here, or here this distributed load, कैसा भी distributed load रहने दो, uniformly distributed or uniformly varying load, clear? Whenever there is a distributed load, that distributed load is also represented graphically also. Now remember, when we represent the distributed load graphically, here the height of that graphical figure represents the intensity. Here the height is represented, this intensity is represented by the height of that graphical figure. Here, so for example, suppose when UDL is spread over the length of L meter, I am taking the same case, let it is spread over a length of L meter. Here, and at the beginning, I told you that the height represents the intensity. At this beginning, let the intensity 0. Intensity 0 means height 0 hai. Here, and this intensity, sorry, I made a mistake. Let at this point, starting point, let the intensity is W. Here, this height represents the intensity. Here, with suitable scale. You don't have to take the scale and all these things. Here, just remember, this height represents the intensity. So, let it is W kilonewton per meter. Here, and in case of the UDL, this intensity is remain constant. Here, means this height of the loading diagram is height of the loading diagram represents constant. Here, so here also it is W kilonewton per meter. Here, and when it represented by such a graphical figure, geometrical figure, here this height represents the intensity and small arrows indicate in which direction the load is acting. Means this load is acting vertically downward. Understood? Here now, in case of a UDL, here since the height or it is a uniformly distributed load and that intensity represented by the height, that's why in case of the UDL, the height is remain constant. Here, that's why this UDL is also known as a rectangular load. इसको और क्या बोलते हैं? Rectangular load. Why? Because when it represented by the graphical figure, here its shape looks like a rectangle. That's why it is also known as a rectangular load. Understood? Here, so UDL may represent by such type of semicircular pattern or by such type of rectangular figure. Okay. Now, while solving the sum, you need to convert this UDL into an equivalent point load. Yeah. For further calculation, for calculation of the support reactions, you need to convert this UDL into an equivalent point load. Now, how to convert the UDL into an equivalent point load? When we convert the UDL into an equivalent point load, what will be the magnitude of that equivalent point load? What will be the direction of that equivalent point load? And at what point or what will be the point of application of that equivalent point load? Here. So remember one thing. Whenever we represent any loading diagram by such type of graphical figure, here the equivalent point load always act at the centroid. कहाँ पे act होता है? वो geometrical figure के centroid पे. Here याद रखो. कहाँ पे equivalent point load कहाँ पे act होता है? Centroid पे. और उसका magnitude कितना रहता है? So magnitude is equal to the area of the figure. Area of that geometrical figure. Okay. Here for any loading diagram, whether it is a UDL, UVR or any other type of varying load. Here, equivalent point load always acts at the centroid and its magnitude is equal to the area of that geometrical figure. Understood? Here, now how to convert this UDL into an equivalent point load? Let's consider this. Now this length is L, and we know that the equivalent point load acts at the centroid of this rectangle, and we know that the centroid of a rectangle lies at its center midpoint. So this is the centroid. This distance is L by 2, right? Yeah. So the equivalent point load will act through the centroid of that point, centroid of that rectangle. Here, and this arrow indicates the direction. Now, since the arrows are downward, so this equivalent point load will also act downward. Understood? Here, now what will be the magnitude of that equivalent point load? It is equal to the area of this rectangular figure. How much is the area? It is in height into length, which it is equal to the product of the intensity and the length. So magnitude of this equivalent point load equal to W into L. Here I have understood this. Here once again, listen carefully. Now when it is represented by such a semicircular pattern, here, now how to convert it into equivalent point load? Same concept, but I will put it another way. Then this UDL is represented by such a semicircular pattern. Remember, the equivalent point load acts at the midpoint of the length over which it is spread. जितने लेंथ पे spread हुआ है, यार equivalent point load उसके center पे act होता है, बीच में. Okay, here means if this is the length L, so equivalent point load will act at this point, means at a distance of L by 2 from this end. Here then equivalent point load will be perpendicular to the base of that semicircular pattern. ये semicircular pattern का जो base है ना, उसको perpendicular रहता है. Understood? Here, and directed toward the base of that semicircular pattern. Directed toward the base of that semicircular pattern. Semicircular pattern का base downward है. So it is downward toward the base of that semicircular pattern. And what will be the magnitude of that equivalent point load? It is equal to the product of the intensity and the length. Here it is W kilonewton per meter. 1 meter पे W kilonewton. So how much is the total load on the L meter? So it is W into L. Here, so how much is the intensity of this? Sorry, magnitude of this equivalent point load? It is W into L. So remember the equivalent point load. यहाँ पे देखो या तो यहाँ पे देखो. The equivalent point load for the UDL acts at the midpoint of the length over which it is spread, directed toward the base of that semicircular pattern, or here directed toward the direction of that loading, perpendicular to the base. Here, and magnitude is equal to the product of the intensity and the length over which it is spread. Okay, here, and once you convert this UDL into an equivalent point load, don't consider this UDL in further calculation. इसको consider नहीं करने का, क्योंकि हमने उसको equivalent point load में convert कर दिया है. Here, so in beam reactions, whenever you are going to draw the free body diagram, here in that free body diagram, instead of this distributed load, here you have to show the equivalent point load. Instead of the distributed load, you have to show the equivalent point load. Understood? Here, any doubt? एक बार कन्वर्ट करने के बाद में ये यूडीएल कंसीडर नहीं करने का, इक्विवेलेंट पॉइंट लोड ही कंसीडर करने का फॉर द फर्दर कैलकुलेशन. Okay, here, so this is all about the UDL. Now sometimes the UDL may act like this also. यार ऐसा भी UDL रहेगा, मतलब रेक्टेंगुलर लोड से दिखाए तो ऐसे रहेगा. Now, where equivalent point load will act, equivalent point load will act at the midpoint of this length over which it is spread. कैसे आएगा? Perpendicular to this base. Okay, ये base को perpendicular, directed toward the base of that semicircular pattern. And what will be the magnitude? The magnitude is equal to the intensity into length over which it is spread. Okay. Understood? Yeah. Then, अभी देखो, my drawing is not that good. Let's consider this is one aeroplane. Here, these are the wings of the aeroplane. Okay, and on the wings of the aeroplane, the lift force is acting. Here, so I'm showing this front view. ये direction से मैं front view दिखाता हूँ. So this is the length. यहाँ से लेके यहाँ तक का ये length है wings का. Okay, यार, और यहाँ पे ऐसा लिफ्ट फोर्स एक्ट होता है, isn't it? Yeah, so we can consider this lift force acting on that wings here as a UDL. Yeah, this is a uniformly distributed. Here, it is a uniformly distributed. Here, so this UDL, how it will act, how you can show it? Here, you have to show it in this way because it is upward. Yeah, this is a representation of that UDL. Now, when we convert it into equivalent point load, वो कहाँ पे act होगा? That equivalent point load for this UDL, which is acting on the wings of that aeroplane, here acts at the midpoint of the length over which it is spread, here and vertically upward, here toward the base of that semicircular pattern. So UDL downward भी रह सकता है, incline भी रह सकता है, upward भी रह सकता है. Understood? Clear? Any difficulty in UDL? So can you convert the UDL into an equivalent point load? Here, listen, theory is important. Here, ये sum सबसे easy sum है. इसका जो sum रहेगा ना, that are most easiest part in the engineering mechanics. Okay. Now, second type of load is the uniformly varying load. Second type of load is the uniformly varying load. In short, it is known as a UVL. Now, this UVL is also a distributed load. Okay, ये UVL भी distributed load ही है. Yeah, लेकिन इसका distribution कैसा है? Let it distributed over the length of L meter. Let it spread over a length of L meter or distributed over a length of L meter. Okay. लेकिन ये distribution कैसा है? ये distribution uniform नहीं है. लास्ट किसके जैसा? Distribution uniform नहीं है. ये distribution कैसा है? Varying है. वो distribution vary हो रहा है. यार, लेकिन वो variation कैसा है? वो variation uniform है. Variation is uniform. Yeah, that's why it is known as a uniformly varying load. Yeah. Now let's consider at this point the intensity is 0. यहाँ का intensity कितना है? 0. I told you that when we represent it graphically, the height represents the intensity. Here, so let at this left end the intensity 0 है. Here, and at this right end the intensity is W kilonewton per meter. Intensity is written as the kilonewton per meter or Newton per meter. Okay. And I told you that this intensity represented by the height of that geometrical figure. So this height represents the intensity, which is W kilonewton per meter. यहाँ का intensity 0 है, यहाँ का intensity W kilonewton per meter है. ये मतलब intensity change हो रहा है, vary हो रहा है. यार, लेकिन ये variation जो है over the length L meter, वो variation is uniform, यार, or linear. That's why it is known as a uniformly varying load. यार, ये देखो, ये vary हो रहा है, intensity vary हो रहा है. ओके, दिस इंटेंसिटी वैरी हो रहा है, लेकिन ये वेरिएशन कैसा है? वेरिएशन यूनिफॉर्म है. यार, मींस अगर ये 1 मीटर में जितना वैरी हो रहा है उतना ही ये 1 मीटर में वैरी होगा. मींस द स्लोप इज रिमेन कांस्टेंट. यार, और इट इज अ लीनियर वेरिएशन. यार, सो सच टाइप ऑफ लोड इज नोन एज अ यूनिफॉर्मली वैरिंग लोड. यार, नाउ शेप ऑफ दिस फिगर इज लाइक अ ट्रायंगल. दैट्स व्हाई इट इज आल्सो नोन एज द ट्रायंगुलर लोड. पहला रेक्टेंगुलर लोड था, ये ट्रायंगुलर लोड है. Because the shape of the loading diagram is like a triangle, that's why it is known as a triangular load. Here, जिसमें intensity एक साइड का intensity 0 है और यहाँ का intensity W kilonewton per meter है. Okay, which is spread over a length of L meter. Clear? ये clear हो गया क्या कि triangular load क्या है? Okay. Now the next point is that here we have to convert it into equivalent point load. Here इसको equivalent point load में convert करने का है. Okay, तो सेम कंसेप्ट जो रेक्टेंगुलर लोड में बोला था वही सेम कंसेप्ट इधर भी यूज करने का है. Whenever any loading is there, here equivalent point load always acts at the centroid of that loading diagram. Here this triangle is a loading diagram. This is known as a loading diagram. Here हमने उसको रिप्रेजेंट किया है, वो लोड को. Okay, so equivalent point load always acts at the centroid of the loading diagram and act at the centroid of that loading diagram, and the magnitude is equal to the area of that loading diagram. Okay, now we know that since it is a triangular load, the centroid of the triangular load will be at a distance of, अगर ये base B है, listen, what is the position of the centroid of a triangle? If the base is B, then this distance will be 2B by 3 from vertex, and from right angle this is B by 3. So centroid of a right angle triangle is 2B by 3 from the vertex and B by 3 from the right angle. So equivalent point load for the triangular load act at the centroid. Here, perpendicular to the base. It is perpendicular to the base and directed toward the arrows. Here arrow are downward, so it will be downward. If this arrow would have been upward, it will act upward. Understood? Here, so this equivalent point load act at the centroid. Here, यहाँ पे centroid पे act होता है. Then, what is the exact length or what is the exact position of this equivalent point load which act at the centroid? अगर base है L here, so this distance will be 2L by 3, and this will be L by 3. So here it is 2L by 3, and this will be L by 3. Then what is the magnitude of that equivalent point load? It is equal to the area of this triangle. Here, so it is half into L into W. This is the magnitude of that equivalent point load. Understood? Here, is that clear how to convert the UVL into an equivalent point load? Here. Now next. Okay, I'm going to tell you the next type of load. Here. Now suppose, idhar dhyan do. One load is spread over a length of L meter. Here, let the initial intensity is 0, and over this length the intensity becomes W. Over the length intensity becomes W kilonewton per meter. Here, मतलब this load is also the varying load. The intensity vary हो रहा है, so it becomes the varying load. Clear? लेकिन ये जो वेरिएशन है ना, ये केस में ये वेरिएशन जो है ना, वो यूनिफॉर्म नहीं है. Clear? That variation is not a linear variation. It is not a uniform variation. Clear? It may be some different variation, or it may be the parabolic variation. ऐसा parabolic variation रह सकता है उसका. Clear? जिसका इक्वेशन दिया रहेगा. Here this W equal to 1 by 2 kx square, like this something. Okay. Here इसका equation दिया रहेगा. Means it may be the parabolic variation. Here. So this is also the varying load. ये दोनों distributed load है. दोनों distributed load में intensity vary हो रहा है. लेकिन यहाँ पे variation कैसा है? It is uniform. Here यहाँ पे variation कैसा है? This variation is a parabolic. Here, that's why this load is also known as a parabolic load. Here, इसको भी equivalent point load में convert कर सकते हैं. उसका भी equivalent point load ये parabola के ये जो figure है, इसके centroid पे act होगा. इसका भी magnitude is equal to the area under this parabola रहेगा. Okay, but this is not in your syllabus. Here, so you don't have to bother about that. Clear? मैंने इसके लिए explain किया कि just आपको समझ में आ सके कि uniformly varying load क्या है. Yeah, so this is also varying load, this is also varying load. इसमें variation uniform है, इसमें variation uniform नहीं है. Understood? Yeah, this is not in your syllabus, so you don't have to bother about this. Okay. Now I'm going to tell you one more type of load, and you have to tell me कि ये कौन से type का load है. Okay. Now listen, suppose one load is spread over a length of L meter. Clear? यहाँ पे initial intensity 0 था. Let here the initial intensity is there. It is not 0, and let this initial intensity is W1 kilonewton per meter. This height represents the intensity. So it is W1 kilonewton per meter, and over the length of L meter it becomes W2 kilonewton per meter. This total height represents the intensity, जो बन गया W2. Clear? So this intensity vary हो रहा है. Clear? और ये variation कैसा है? This variation is a linear variation. Clear? Here I got such type of figure. Now since the shape of the loading diagram is like a trapezium, yeah, that's why this is also known as the trapezoidal load. इसको क्या बोलते हैं? Trapezoidal load. Clear? Now tell me, out of these two, मैं और आपका आंसर नैरो कर देता हूं. आउट ऑफ दिस टू यूडीएल एंड यूवीएल, ये जो ट्रैपेजॉइडल लोड है, ये कौन से टाइप का लोड है? इज इट यूवीएल? कैसे है ये?
दोनों टाइप का सर.
दोनों टाइप का कैसे हुआ? दोनों टाइप नहीं है, ये एक ही टाइप है. इधर यूडीएल है या नहीं तो यूवीएल है. दोनों टाइप का कैसे बोल सकते हैं आप?
यूवीएल है सर.
इट इज अ यूवीएल. वो वैरी हो रहा है ना, इंटेंसिटी वैरी हो रहा है या नहीं? सिंस द इंटेंसिटी वैरी हो रहा है, सो इट इज वैरिंग लोड. और वो वेरिएशन कैसा है? लीनियर है, मतलब इट इज अ यूनिफॉर्मली वैरिंग लोड. अंडरस्टूड? यार ओनली यहाँ पे इनिशियल इंटेंसिटी होने की वजह से इट शेप लुक लाइक अ ट्रैपेजियम, दैट्स व्हाई इट इज नोन एज अ ट्रैपेजॉइडल लोड. अंडरस्टूड? यार, सो दिस इज अ यूवीएल, अभी ये जो यूवीएल है, ये जो ट्रापेजॉइडल लोड है, ये ट्रापेजॉइडल लोड भी हम लोग सिंगल इक्विवेलेंट पॉइंट लोड में कन्वर्ट कर सकते हैं यार। ये पूरा का पूरा लोड एक ही पॉइंट लोड में कन्वर्ट कर सकते हैं यार। वो पॉइंट लोड में कन्वर्ट करने के लिए आपको क्या लगेगा, वो इक्विवेलेंट पॉइंट लोड जो आएगा, दैट इक्विवेलेंट पॉइंट लोड विल एक्ट एट द सेंट्रोइड ऑफ दिस ट्रापेजियम, एंड इसका एरिया कितना, सॉरी इसका मैग्नीट्यूड कितना आएगा, इक्वल टू द एरिया ऑफ द ट्रापेजियम। ओके, here it is not difficult to calculate the area of the trapezium, but again it is little bit difficult to calculate its centroid. You have to find out the point of application of that equivalent point load. यह centroid calculate करना little bit difficult है, again उसके लिए कुछ calculation करना पड़ेगा। Okay, so instead of that, instead of converting this trapezoidal load of this UVL into a single equivalent point load, here the easiest method is, here instead of converting it into single equivalent point load, the easiest method is that what we are going to do, here we are going to split this trapezoidal load into two parts. हम इसको दो पार्ट में स्प्लिट करेंगे। Here one is a rectangular load and other one is a triangular load. किसके लिए कन्वर्ट कर रहे हैं, जस्ट स्प्लिट कर रहे हैं, जस्ट टू कन्वर्ट इट इनटू इक्विवेलेंट पॉइंट लोड। हम लोग सिंगल पॉइंट लोड में भी कन्वर्ट कर सकते हैं, लेकिन डिफिकल्टी इज दैट वी नीड टू कैलकुलेट द पोजीशन ऑफ द सेंट्रोइड इन दैट केस हियर। So to avoid that, I'm going to split it into two parts. One is a rectangular load, other one is a triangular load. Understood? Here मैं इसको split कर रहा हूँ, rectangular load है, triangular load में, doesn't mean that कि ये जो load है, it is a combination of, और ये दोनों टाइप का लोड है, UDL भी है और UVL भी है, ऐसा नहीं है, ये UVL ही है, लेकिन for my convenience I'm splitting it into two parts. Okay? Here इसको दो पार्ट में split करूंगा। यार एक रहेगा रेक्टेंगुलर लोड जिसका इंटेंसिटी रहेगा W1, और दूसरा रहेगा ट्रायंगुलर लोड जिसका इनिशियल इंटेंसिटी रहेगा 0, एंड यहाँ का इंटेंसिटी ये देखो, ये W1 है, टोटल इज W2। so how much is the height of this triangular load? Here it is W2 minus W1, isn't it? Height of the triangle, are you getting it or not? Clear? So we have split it into two parts. Here, then convert this rectangular load into one equivalent point load, here which will act at the midpoint of the length. So this will be L by 2, and magnitude of that equivalent point load for the rectangular load here will be W1 into L. It is W1 into L. This is the equivalent point load for the rectangular load. And for triangular load, what is the equivalent point load which will act at the centroid of a triangle? Remember, the centroid of a triangle is little bit closer to the right angle. Midpoint में मत दिखाओ, okay? Then what is the equivalent, position of that equivalent point load for the triangular load? It is 2L by 3 from the vertex, or L by 3 from the base. Here because base is equal to L, so it is L by 3 from this right angle corner, or 2L by 3 from the vertex here. And what will be the magnitude of that equivalent point load? It is equal to the area of this triangle. So how much is the area of this triangle? It is half into L into height of the triangle. How much is that? It is W2 minus W1. W2 नहीं, W2 को दो पार्ट में स्प्लिट कर दिया है, W1 and remaining part. So remaining height is W2 minus W1. Here, so whenever there is a trapezoidal load, you have to split it into two parts, rectangular and triangular, and convert it into two equivalent point load instead of one. ऐसा नहीं है कि सिंगल पॉइंट लोड में उसको कन्वर्ट नहीं कर सकते, कर सकते हैं, ओके, लेकिन वो उसका पॉइंट ऑफ एप्लीकेशन कैलकुलेट करना लिटिल बिट डिफिकल्ट हो जाता है। दैट्स व्हाई इट इज बेटर टू स्प्लिट इट इनटू टू पार्ट। एनी डाउट? दिस इज द एंड ऑफ द बीम रिएक्शन, सॉरी टाइप्स ऑफ लोडिंग। एनी डाउट? समझ में आया क्या आपको?
हाँ सर।
इसका थ्योरी है ना, रिजल्टेंट में दिया है, और रिजल्टेंट के क्वेश्चन बैंक में there are few questions of finding the resultant of a distributed force system. तो आपको क्या करने का है, वो distributed force system को equivalent point load में convert करने का है, और फिर उसका resultant calculate करने का like a normal sum. Understood? Here, if time permits, I will take that one questions on that. Okay. So types of support हो गया, types of load हो गया. Here, now in 5 minutes, I am going to tell you about the types of beams, because we have to calculate the beam reaction. Na? So which are the different type of beam? Here, the first type of beam is simply supported beam. simply supported beam. Now, what is in the simply supported beam? Here, when the beam is supported at two extreme ends, here, when the beam is supported at its two extreme ends, here, with the help of some hinge support and the roller support. Here, so when the beam is supported at its two extreme ends, then loading कुछ भी रहने दो, UDL रहेगा, UVL रहेगा, incline point load रहेगा, कुछ भी रहेगा. But when the beam is supported at its two extreme ends, here such type of beam is known as a simply supported beam. Second type of beam is the cantilever beam. Cantilever beam. Here, in cantilever beam, the beam is supported only at one end. Either is support रहेगा, other end is remain free. Here, so when a beam is supported at one end and other end is free, here such type of beam is known as a cantilever beam. Here, अभी ये cantilever beam में एक ही support use करके, here ये cantilever beam में एक ही support use करके मुझे उसको horizontal equilibrium में रखने का है. ओके, तो सपोर्ट कैसा लगेगा? इधर इधर हिंज सपोर्ट चलेगा क्या? ऐसा हिंज सपोर्ट चलेगा क्या?
No,
क्या
sir.
होगा? क्या होगा?
नो सर,
Concrete support.
अगर मैंने इधर एक ही सपोर्ट लगा के मुझे हॉरिजॉन्टल रखने का है, और अगर इधर मैंने पिन जॉइंट या तो हिंज सपोर्ट लगा दिया, क्या होगा? बिकॉज ऑफ सम एक्सटर्नल फोर्स और इटसेल्फ ये रोटेट हो जाएगा. It will remain in horizontal equilibrium, isn't it? Here, so to hold it in equilibrium, मुझे वो rotational motion भी restrict करने का है. That's why whenever the cantilever beam is there, here which is at one end it is supported and other end is free. Here then at this end there must be the fixed support. इधर fixed support ही आएगा. Here, so when a beam is supported at one end and other end is free, here such type of beam is known as a cantilever beam. Here, एक ही end पे supported है, other end free है. Such type of beam is known as a cantilever beam. Here, that projected part outside the window. Here, और घर में shelf रहता है. Here, that is nothing but a cantilever. एक end पे fix रहता है, दूसरा end free रहता है. Here, और these shopkeepers make the shade in front of their shop. Here, ऐसा shop का shutter है. Here, तो इसके shutter के बाहर ऐसा shade बनाते हैं. अंडरस्टूड? यार इसको क्या रहता है? एक ही एंड पे फिक्स किया रहता है, दूसरा एंड फ्री रहता है. या फिर इट इज वन टाइप ऑफ कैंटिलीवर सपोर्ट और कैंटिलीवर बीम. ओके यार, तो सेकंड टाइप ऑफ बीम इज अ कैंटिलीवर बीम. यार, एंड थर्ड टाइप ऑफ बीम इज ओवरहैंगिंग बीम. Overhanging beam. Now, what is the overhanging beam? When the beam is extended beyond the support. यार अभी ये बीम देखो, ये सिंपली सपोर्टेड हो गया यार, लेकिन ये बीम को यहाँ पे सपोर्ट दिया और ये पार्ट जो है ना बीम का, ये सपोर्ट के भी बाहर एक्सटेंडेड है. यार सपोर्ट के बाहर एक्सटेंड है. तो फर्स्ट टाइप ऑफ बीम यार व्हेन इट इज एक्सटेंडेड बियॉन्ड द सपोर्ट इज नोन एज द ओवरहैंगिंग बीम. इतना पार्ट ओवरहैंग हो गया. यार दिस पार्ट इज नोन एज द ओवरहैंग पार्ट. Yeah, so when the beam is extended beyond the support, it is known as the overhanging beam. Here, understood? These three types of beams are important from your subject point of view. Here, most of the time, 99% time आपको figure दिया रहेगा. उससे first step you have to draw the FBD. Here and then apply the conditions of equilibrium. Here, beam के reaction में जो force system बनेगा, that will always a general force system. It will be a general force system. So you have to apply the three conditions of equilibrium, and by using the three conditions of equilibrium, you can find at the most three unknowns. Okay? हाँ बोलो.
सर कैंटिलीवर बीम भी तो ओवरहैंगिंग बीम हो गया ना, एक ही सपोर्ट पे है ना.
हाँ, लेकिन इसको कैंटिलीवर बोलते हैं यार. एंड सच दिस बीम एक ही सपोर्ट है यार, बट व्हेन वन सपोर्ट इज देयर एंड इफ इट इज अ फिक्स्ड एंड अदर एंड इज फ्री, दिस इज नोन एज अ कैंटिलीवर.
तो सर वही है, ओवरहैंगिंग बीम में भी हो रहा है ना.
सेम है, लेकिन ओवरहैंगिंग बीम में इधर फिक्स सपोर्ट नहीं रहता है. दिस इज द रोलर और हिंज सपोर्ट. क्लियर? एंड ओवरहैंगिंग बीम मे बी ओवरहैंग और एक्सटेंडेड ऑन वन साइड और मे बी ऑन बोथ साइड. अंडरस्टूड? क्लियर? कैंटिलीवर अगर बोलेंगे तो ये सपोर्ट फिक्स ही रहेगा, बट ओवरहैंगिंग में ये दो सपोर्ट रहेंगे यार, एंड एक हिंज और एक रोलर रहेगा. उधर फिक्स सपोर्ट नहीं रहेगा ओवरहैंगिंग में.
ओके सर.
ओके क्लियर? एंड ओवरहैंगिंग मे बी ऑन ईदर साइड. Clear? Now, ऐसा बीम रह सकता है क्या? और अगर रहेगा तो क्या डिफिकल्टी आएगा? सपोज दिस इज वन बीम, ओके, एट वन एंड यहाँ पे इट इज सपोर्टेड विद हेल्प ऑफ हिंज, उस पर कुछ लोड एक्ट हो रहा है, एंड एट दिस एंड ऑल्सो देर इज अनदर हिंज, बोथ एंड पे हिंज सपोर्टेड है, ओके यार। ये जो बीम दिखा है मैंने स्ट्रक्चर का, यार ये बीम पे क्या है ना, ये देखो, ये एंड पे भी फिक्स किया है और ये एंड पे भी फिक्स किया है, इधर भी फिक्स है इधर भी फिक्स है। ये बीम में मैंने कंसीडर किया इधर रोलर है इधर रोलर है। यार फ्रॉम आवर सब्जेक्ट पॉइंट ऑफ व्यू ऑफ इंजीनियरिंग मैकेनिक्स, यार व्हाट इज डिफिकल्टी ओवर हियर? ऐसा बीम आ सकता है कि अपने सिलेबस में? अगर आएगा तो इसमें क्या डिफिकल्टी आएगा? लिसन, इसमें क्या डिफिकल्टी आएगा? जब मैं इसका एफबीडी ड्रॉ करूंगा ना, तो यहाँ पे हिंज है, तो देयर विल बी द टू अननोन, या देयर विल बी द टू कंपोनेंट ऑफ रिएक्टिव फोर्सेस, एच एंड वी। सिमिलरली यहाँ पे भी हिंज है, तो यहाँ पे भी दो कंपोनेंट ऑफ रिएक्टिव फोर्सेस आएंगे, हियर इट इज एच बी एंड वी बी। So when I will draw the free body diagram of this, yeah, which become a general force system, and when this general force system is in equilibrium, I can apply only three conditions of equilibrium. By using the three conditions, I can get the three equations, and by using three equations, I can calculate only three unknowns. लेकिन यहाँ पे कितने unknowns है? Suppose if all the loading is given, या reactive forces में कितने unknowns है? So there are four unknowns, isn't it? यहाँ पे दो है और यहाँ पे दो है, so all together how many unknowns are there? There are four unknowns here, and we cannot calculate that four unknowns by using all the four unknowns by using these three conditions of equilibrium. Understood? Clear? So और calculate कर सकते हैं, we can calculate them, but not only by using the conditions of equilibrium. You have to use some other principle for that. नीचे का बीम अगर देखेंगे जो दोनों एंड से फिक्स है, तो इधर तीन अननोन आएंगे इधर तीन अननोन आएंगे, इसमें सिक्स अननोन आ सकते हैं, वो सिक्स अननोन भी हम लोग कैलकुलेट कर सकते हैं, बट नॉट ओनली बाय यूजिंग द कंडीशंस ऑफ इक्विलिब्रियम, यू हैव टू यूज सम अदर प्रिंसिपल। अंडरस्टूड? हियर एंड देन द सपोर्ट रिएक्शन cannot calculate only by using the conditions of equilibrium. Such type of beam is known as a indeterminate beam, or such type of structure is known as the indeterminate structure. Here, this indeterminate structure is not in your syllabus. आपको determinate structure ही आएगा, जिसमें you can calculate the support reactions only by using the conditions of equilibrium. Okay, here you don't have to learn that other principles how to find out that support reactions. Clear? Let it be now. Okay, so आपको तीन अननोन का ही सम आएगा. Okay, now we'll solve the sum. Here, I got the printout. Question bank का printout निकाला क्या? Listen, nearby you all the Xerox shops and printing shops are available or open now. College बंद है इसलिए shops भी बंद नहीं है. You get the printout. क्लियर? डायरेक्टली सॉफ्ट कॉपी से यूज मत करो. We'll solve sum number 3. Sum number 3. Figure is given. Find the support reactions at A and B for the beam shown in the figure. Here beam is given. I am drawing that beam. At A there is a hinge support. Here then this point is A. At a distance of 2 meters, one UVL starts. Trapezoidal load है, which spread over a length of 6 meters. This intensity is 20 kilonewton per meter and varies linearly and become 80 kilonewton per meter. Okay, over a length of 6 meters, and the small arrows are shown downward, means this load is acting downward. Okay, then after 2 meters, here यहाँ पे one roller support is there, and that roller is resting on an inclined surface. Here there may be some practical difficulty, technical difficulty, so that we cannot use this hinge roller on horizontal surface. So inclined surface पे rest कर दिया. Clear? This roller is resting on an inclined surface whose inclination is 30 degrees with horizontal. This point is B. Okay. here, and this is 60 kilonewton, sorry, 80 kilonewton at a distance of 3 meter from B. Here, for this loading, you have to calculate the support reactions at A and B. What is the first step? The first step is to draw the free body diagram. Here, FBD of beam. आपने ये given figure नहीं draw किया तो भी चलेगा. Here, directly draw the FBD. Here, कितना भी बड़ा सम रहने दो, कितना भी लंबा बीम रहने दो. Here, कितना भी number of forces रहने दो. Here, these sums can be solved only in 3 steps. FBD and 3 conditions of equilibrium, you will get the answer. Here, FBD, draw the FBD properly. FBD carries the mass. Okay, therefore I am drawing the FBD of this beam. This is the beam. Now in FBD, क्या करने का है? Instead of support, you have to show the support reaction, and instead of this distributed load, you have to show the equivalent point load. That's all. Here, now at A, there is a hinge support. Now, as there is a hinge support, how many unknowns are there at the hinge support? There are 2 unknowns. Here, one is a horizontal component of the reactive force, one is a vertical component of the reactive force. Here, what about the direction of this component? So, initially you have to assume. I am assuming that J upward, HA towards right. आप कौन सा भी direction assume कर सकते हैं. खाली याद रखो कि with that assumed direction अगर positive answer आता है तो assumed direction is correct, and negative answer आता है तो assumed direction is opposite to that what we have assumed. Okay. Therefore, instead of hinge support, you have to show the support reaction here at point A. Then after 2 meter, this is the 2 meter. This 2 meter to 6 meter. ये distance, show the distances properly. ये 6 meter पे UVL है. और ये UVL trapezoidal load है. Yeah, so how to convert the trapezoidal load into equivalent point load? So split it into 2 parts. Yeah, so इसका एक equivalent point load आएगा rectangular load का, और ये triangular load का एक equivalent point load आएगा. So what is the equivalent point load for the rectangular load? That will act at the midpoint of this length. Here arrows are downward, so it is downward, and it is midpoint of the length over which it is spread. So this distance is 3 meter. What is the magnitude of that equivalent point load? Here its intensity is 20 and spread over a length of 6 meters. So 20 into 6. Directly 120 लिखा तो भी चलेगा. It is 120 kilonewton. Equivalent point load for the rectangular load. Then equivalent point load for this triangular load. Now we know that the equivalent point load for the triangular load acts as its centroid. Here, and we know that the centroid of a triangle here is at a distance of 2b by 3 from the vertex. ये vertex है. यहाँ से 2b by 3. या तो ये right angle से l by 3. Means this distance will be l by 3. That is 6 by 3. So this distance will be 4 meter and this is 2 meter. कौन सा भी एक लिखो. But write the distances properly. Yeah, this total distance is 6 meter. Yeah, now this equivalent point for the triangular load at a distance of 2b by 3 from the vertex means at a distance of 4 meter. और इसका magnitude कितना आएगा? Can anybody tell me what is the magnitude of that equivalent point for the triangular load? Unmute yourself. Rakesh Chauhan, roll number 9. Are you there?
Yes, sir.
Tell me.
Yes, sir.
Tell me. What is the equivalent point load for this triangular load?
The screen is freezed. स्क्रीन फ्रीज हो गया.
हाँ फ्रीज है.
Dipesh Bhatt.
Yes, sir.
Tell me how to convert that triangular load into equivalent point load. ये रेक्टेंगुलर लोड को इक्विवेलेंट पॉइंट लोड में कन्वर्ट कर दिया यार, ये ट्रायंगुलर लोड को इक्विवेलेंट पॉइंट लोड में कन्वर्ट कैसे करने का? अरे बोलो कुछ तो भी, मैं सिर्फ बोलने के लिए बोल रहा हूं. आई एम नॉट आस्किंग यू टू स्टार्ट योर वीडियो. और क्या पढ़ाने का आप लोगों को? कैसे पढ़ाने का?
सर वो सेंट्रॉइड पे लाई करेगा ट्रायंगल के.
अरे हाँ तू बोल रहा है, लेकिन व्हाट अबाउट द अदर? वो सेंट्रॉइड पे लाई करेगा तो वो तो मैंने ही बोल दिया कि सेंट्रॉइड पे लाई करेगा. क्लियर? एट द सेंट्रॉइड ऑफ अ ट्रायंगल विच इज एट अ डिस्टेंस ऑफ 2l/3 और 2b/3. उसका बेस 6 मीटर है, तो 2b/3 तो एट अ डिस्टेंस ऑफ 4 मीटर फ्रॉम दिस पॉइंट. ये इधर आएगा. मेरा क्वेश्चन है इसका मैग्नीट्यूड कितना रहेगा?
एरिया होगा सर ट्रायंगल का.
ट्रायंगल का एरिया होगा. ट्रायंगल का एरिया होगा. कितना इजी है देखो, कितना इजी है. ये ट्रायंगल का एरिया होगा. क्लियर? लेकिन मैंने 2-3 स्टूडेंट्स को क्वेश्चन पूछा कि दे आर नॉट एबल टू आंसर. क्यों नहीं? चौहान, दैट भट्ट, क्यों नहीं आंसर आ रहा है आपको? यार अगर ऐसा है और ऐसा अगर समवर्क में कम मार्क्स मिला तो डोंट ब्लेम टू मी कि सर हम लोगों को कैसे मिला. सब तो ऑफलाइन है सर, सब तो ऑनलाइन थे, कोई भी तो कॉलेज में नहीं था. यार मेरे पास सब रिकॉर्ड है कि किसको क्वेश्चन पूछा, किसने आंसर दिया, किसने अनम्यूट नहीं किया, सिर्फ लॉगिन करके चले गए किधर. So the magnitude of this equivalent point load is equal to the area of this triangle. How much is the area of this triangle? It is half into base. Base is 6 meter into height of the triangle चाहिए मुझे खाली. Here the total height is 80. 80 में से 20 मैंने ये UDL के लिए यूज किया, रेक्टेंगुलर लोड के लिए यूज किया. So remaining height or remaining intensity is 60. Here so it is half into 60. So half into 6 into 60. Here so which is equal to how much? 180 kilonewton. This is the equivalent point load for the triangular load. यार अभी इसके बाद में किसी को भी पूछने हुआ ना तो आना चाहिए. अगर मुझे आंसर नहीं आया किसी का मैंने पूछने के बाद, या तो समझ लो आप फेल हो गए ओरल में. Okay. Here then from this one 2 meter onward, from this point, listen, from here to here this is 6. उसके बाद में ये 2 है. Here at this point B, here there is a roller support. Roller is resting on this inclined surface. So at the roller support, the reaction is perpendicular to the supporting surface. Reaction is perpendicular to the supporting surface. Here, so this reaction you have to show like this. Now it is in direction you can initially assume this is RB, which is perpendicular to the supporting surface. Now since it is perpendicular to the supporting surface and the surface makes angle of 30 degree with horizontal, इसका inclination with horizontal के साथ 60 होगा. Here this 60 means this angle is 60, alternate angle. Okay, and at a distance of 3 meter beyond that support, here this force is 80 kilonewton. Here this become the free body diagram. Here now this become a general force system which is in equilibrium. Beam is always in equilibrium. So by applying the condition of equilibrium, we have to calculate the support reaction. Here now for applying the condition of equilibrium, जो inclined force है उसको resolve करो. So this is the only inclined force. I am resolving it into two components. Here if this angle is 60, so this component is RB cos 60 and this is RB sin 60. I hope that all of you are comfortable with this resolution. Here resolution में किसी को difficulty नहीं होगा. Here now apply the three conditions of equilibrium. Now in general force system, when we apply the conditions of equilibrium, here personally मैं suggest करता हूँ कि पहले moment का condition use करो. First use the moment condition. Hard and fast नहीं है, but first use the moment condition. Okay. Here I will personally suggest first use the moment condition. And where to take the moment? Where to take the moment? In equilibrium, here take the moment or select the moment center. Select the moment center. कहाँ पे select करने का? Select the moment center at a point where maximum unknowns are meeting. Where maximum unknowns are meeting. Okay. Here actually when any system is in equilibrium, then the algebraic summation of the moment of all forces about any point has to be equal to 0. तो आप कहीं पे भी मोमेंट ले सकते हैं. यार हार्ड एंड फास्ट नहीं है कि ये यूज करना चाहिए, बट अगर ये यूज किया तो आपका कैलकुलेशन सिंपल हो जाएगा. यार सो इन दिस सिस्टम व्हिच इज द पॉइंट वेयर मैक्सिमम अननोन्स मीट हो रहे हैं, which is the point where maximum unknowns are acting.
Point B.
A is the point where maximum unknowns are there. 2 unknowns यहाँ पे है, तो मैं A पे मोमेंट लेता हूँ. क्या होगा इससे? अगर मैंने A मोमेंट से पॉइंट सिलेक्ट किया तो ये दोनों अननोन जो इसमें से पास हो रहे हैं दोनों का मोमेंट 0 हो जाएगा. या तो ये अननोन दोनों ही अननोन ये इक्वेशन में से एलिमिनेट हो जाएंगे. या अपना इक्वेशन सिंपल होगा जिसमें नंबर ऑफ अननोन ज्यादा नहीं रहेंगे, क्योंकि नंबर ऑफ अननोन अगर ज्यादा है तो अननेसेसरीली कैलकुलेशन बिकम डिफिकल्ट. तो कैलकुलेशन इजी करने के लिए आपको मोमेंट वो पॉइंट पे लेने का है कि जहां पे मैक्सिमम अननोन्स आर मीटिंग, तो ये एलिमिनेट हो जाएंगे. यार नाउ लेट राइट डाउन द इक्वेशन. लेट राइट डाउन द मोमेंट इक्वेशन. algebraic summation of the moment of all forces about point A. Let's start from left support and move to the right. Okay, moment of HA and VA becomes 0. नेक्स्ट फोर्स कौन सा है? नेक्स्ट फोर्स ये 120 है. एक बार ये इसको कन्वर्ट करने के बाद में यही लोड कंसीडर करने का, ये नहीं. नेक्स्ट फोर्स इज 120. इट्स मूवमेंट अबाउट पॉइंट ए, क्लॉकवाइज सो माइनस, क्लॉकवाइज माइनस, एंटी क्लॉकवाइज पॉजिटिव. सो इट इज 120 इनटू इट इज द मोमेंट. सो प्रोडक्ट ऑफ द फोर्स एंड द डिस्टेंस. कितना डिस्टेंस है ए से इसका परपेंडिकुलर डिस्टेंस? सो दिस इज 3 + 2 5. The next force, moment of this 180, that is also clockwise. So minus 180 into perpendicular distance from A. कितना इसका perpendicular distance A? So this is 4 meter plus 2 meter. So it is 6. इसका moment हो गया. Then go ahead for now moment of this RB. RB incline है. So to take the moment of the incline force, let's take the moment of its component. So the moment of this cos component about A is 0 because its line of action passes through A. So इसका moment, ये cos component का moment about A becomes 0. Moment of this sine component about point A is anti-clockwise, so plus. It is RB sin 60. ये हो गया force into its perpendicular distance from A. How much is this perpendicular distance? ये 2 है, ये 6 है और ये 2 है. So it is 10. हो गया moment of RB. Now moment of this 80 about point A, clockwise, so minus 80 into how much is perpendicular distance? This 10 plus 3, 13, which is equal to 0. यार अभी ये इक्वेशन में एक ही अननोन है, दैट इज आरबी. सॉल्व दैट. सॉल्व फंक्शन यूज करो, पूरा इक्वेशन टाइप करो, शिफ्ट सॉल्व 0 इक्वल. नेक्स्ट स्टेप में आपका आरबी आ जाएगा. ओके यार. देन अगर पॉजिटिव आता है तो अज्यूम डायरेक्शन इज करेक्ट. अगर निगेटिव आता है तो अज्यूम डायरेक्शन इज अपोजिट टू दैट व्हाट वी हैव अज्यूम. Here then use the next condition, summation of fx equal to 0. पहले कंडीशन लिखो and then write down the equation. Summation of all x components, h is towards right, so positive. Clear. उसके बाद में एक डायरेक्शन में कौन सा फोर्स है? ये. This is towards left, so minus rb cos 60 equal to 0. Here rb का वैल्यू आपने कैलकुलेट किया, इसमें सब्स्टिट्यूट कर दो, you will get ha. Here then use summation of fy equal to 0. If I use summation of fy equal to 0, summation of all vertical forces. Let's start from left. Upward force positive, downward force negative. So this VA minus 120 minus 180 plus RB sin 60 minus 80 equal to 0. The summation of vertical forces. Here RB का वैल्यू आपने सब्स्टिट्यूट कैलकुलेट किया है, सब्स्टिट्यूट here you will get VA. Yes, so these HA and VA are the component of reaction at point A. After calculation of this HA and VA, calculate the resultant reaction at A. Resultant reaction at A. Here ये दोनों का resultant calculate करने का है. That become RA. and its inclination alpha. So resultant reaction as A, Ra equal to under root of Ha square plus Va square. Just substitute the value and get the answer. And its inclination is alpha equal to tan inverse mod of Va upon Ha. Here, any doubt? Here, ये याद रखो. In general force system, I suggest always use the moment condition first. तो कहाँ पे moment लेने का है? You have to take the moment at that point where maximum unknowns are meeting. Understood? Any difficulty? Here equilibrium का पूरा theory हो गया है. Here और एक lecture लेने वाला हूँ. I'm going to take one more lecture here and we are going to finish that lesson. Okay? Any doubt?
सर आरबी कैसे है एक बार बताओ ना प्लीज.
क्या?
आरबी कैसे है एक बार बताओ ना.
यार I use the moment condition. मैंने तीन इक्वेशन तीन कंडीशन यूज किया. तीन कंडीशन यूज करके मुझे तीन अननोन्स आ गए. यार आरबी कैलकुलेट करने के लिए मैंने मोमेंट अबाउट पॉइंट ए लिया. समेशन ऑफ एम इक्वल टू 0 ये कंडीशन यूज किया और मैंने इसका इक्वेशन लिखा. यहाँ से स्टार्ट किया. सब फोर्सेस का मोमेंट लिखा. एच और वी का मोमेंट 0. 120 का इट इज -120 इंटू इसका परपेंडिकुलर डिस्टेंस 5. देन मोमेंट ऑफ दिस 180 -1 एक क्लॉकवाइज है इसलिए -180 इंटू इसका परपेंडिकुलर डिस्टेंस 4 + 2 6. मोमेंट ऑफ दिस आरबी cos 60 0. मोमेंट ऑफ दिस आरबी sin 60 क्लॉक एंटी क्लॉकवाइज तो प्लस आरबी sin 60 इंटू इसका परपेंडिकुलर डिस्टेंस कितना है 2 + 6 + 2 दैट इज 10. एंड मोमेंट ऑफ दिस 80 अबाउट पॉइंट ए क्लॉकवाइज तो -80 इंटू इसका परपेंडिकुलर डिस्टेंस. तो यहां तक 10 हुआ था +3 13 इक्वल टू 0. ये सॉल्व करो ना ये इक्वेशन.
ओके सर समझा.
आपको आरबी मिल जाएगा और एक इक्वेशन और एक ही अननोन है. सॉल्व फंक्शन यूज करो. नेक्स्ट स्टेप में आरबी मिल जाएगा. कैलकुलेशन शो करने का जरूरत नहीं है. इक्वेशन लिखो आंसर. इक्वेशन लिखो आंसर. दैट्स ऑल. अंडरस्टूड? एनी डाउट?
यस सर.
Which lecture do you have at 9:15?
BEE.
Math.
Okay. I will end the meeting now here. Thank you.